Now we will see importance of YAML in API design. So we have understood what is YAML and why it is so popular. But YAML is a YAML-based modeling language to describe a RESTful API. And there are many necessary and helpful tools in YAML like console, which we can use to test the APIs. Then we have notebook, which are used to validate the APIs. Then we have workbench and YAML server. So let's see what are the uses of these components.
So importance of YAML in API design. YAML seems to be yet another one of the great words in IT space. Many of us know that it has to do with APIs and connectivity, but they are not positive what it is exactly or where to start with. So we already know that YAML is a RESTful API modeling language. It is a YAML-based modeling language to describe RESTful APIs. It provides a structured and clear format to describe the API. According to YAML's website, it makes it easy to manage the whole API lifecycle. YAML can be used in a multitude of ways to implement interactive PAI consoles, generate documentation describing an API you are planning to build, and many more. Despite the name, YAML can describe APIs that do not follow all of the REST rules. So what's a RESTful API? So RESTful API, also known as RESTful Web Services, are formal languages designed to provide a structured description of a RESTful Web API capable of being consumed by both human and machine. They utilize HTTP requests to get, put, post, and delete the data. So RESTful API are the formal languages described and designed to provide a structured description of a RESTful web API capable of being consumed by both human and machine. They utilize HTTP requests to get, put, post, and delete data. Then we have a representational state transfer. So REST is a style of architecture based on a set of principles that describe how networked resources are defined and addressed. It supports the web applications should use HTTP as it was originally thought of. To learn more about what RESTful API, we will try to shed some light. So RESTful uses HTTP protocol for communication purpose for different types of operations. Then we have YAML tools. Benefit of YAML is the library of tools that are offered. They can range anywhere from API document generation to converting APIs developed in other languages over to YAML, or the tool that will help parse, validate, and modify YAML types. So what are the tools of YAML? So we have API console, API notebook, API workbench, YAML server, YAML tools for .NET, some environments, for example, Sandbox. So, console is a graphical user interface that exposes the API structure and important patterns, as well as serving an interactive API documentation. So in some platforms, console can enable the users to test the API without actually running it. So instead of writing any extra code, using console, we can test our API. Then API notebook. It is a web-based JavaScript scripting workspace that enables live testing and exploring of APIs and saving API use cases as markdown gists. Then Workbench. It is a full-featured integrated development environment for designing, building, testing, documenting, and sharing RESTful HTTP APIs. Then YAML server exposes a full fake REST API with zero coding by writing a YAML specification. Then YAML tools for .NET allows developers to easily integrate and consume APIs that expose a YAML definition or create a new ASP.NET Web API implementation from a previously created YAML definition. And Sandbox. It's a quick and easy mock RESTful API and SOAP web services. Generate from API definitions, instant deploy, collaborative build, and debugging tools for integration. So Sandbox is the environment using which we can deploy our APIs and then manage the APIs. So there are other options for designing the APIs. So we have API blueprint, open API specification, which is also known as Swagger, WADL, and YAML. So all of these have their own features, drawbacks, and advantages. But as a whole, YAML is more considered for designing RESTful APIs. So let's see the difference between Swagger and YAML and understand which is better for building APIs. So Swagger, also known as Open API Specification, and YAML are the two most popular specifications for building or developing APIs. But which one should we choose for our business? So we need to understand the difference between them. So first, let's understand about Swagger. So Swagger, as we said, it's also known as Open API Specification. It is a type of framework that was designed to describe, produce, visualize, and consume RESTful web services. Referred to as language agnostic. It has been developed to be read using a common language. README.io produced a perfect example that can be used to help understand exactly what Swagger is. So Swagger is a type of framework that was designed to describe, produce, visualize, and consume RESTful web services. It is referred to as language agnostic. It has been developed to be read using a common language. So you can think of it as blueprint for the house. You can use whatever building materials you like, but you cannot step outside the parameters of the blueprint. Swagger's popularity stems from its simplicity, from its concise documentation to its ease of readability for machines and humans alike. Swagger is a framework that has been made very easy to utilize. So what are the advantages and drawbacks of Swagger? It has a large community with a good support base. It has high adoption rate, which means it has lots of documentation. It has a strong framework support. It has the largest language support of any open source framework. So what are the drawbacks of Swagger? It requires multiple specifications for some tools. It does not allow for code reuse or extensions. It lacks strong developer tools. It requires schemas for all responses. So then what is WAML then? So WAML is a YAML-based language for describing RESTful APIs. As the name implies, it provides all the information necessary to describe RESTful or practically RESTful APIs. YAML is very much a hierarchical style format, which is one of the many reasons it is such an excellent planning tool. By visualizing the cause and effect of requests to the API, as well as documenting specific examples of what return can be expected, APIs can either be documented or planned with incredible granularity. So YAML has many advantages. It has a single specification to maintain. It has strong visual-based IDE and online tooling with collaboration focus. It allows for design patterns. It is very easy to get started with YAML. It has a very simple syntax, very easy to read. And what are the drawbacks of YAML? It lacks strong documentation and tutorials outside of specification. It has limited code for reuse or extensions. Multiple specifications required for several tools, including DEV and QA. It has poor tooling support for new versions. YAML and Swagger are very capable, compatible with many languages. They both offer compatibility in .NET, Java, JavaScript, Node.js, PHP, Python, Ruby, and Scala. Swagger has additional capabilities like Cold Fusion, EFL, Groovy, and TypeScript. YAMLs additional capacities like Elixir and Perl. So as we discussed, we understood that both languages are strong and able to produce excellent APIs, despite their differences. Their key difference is that you can determine which is best for your business. Swagger's best features are its strong documentation and compatibility. With less used languages. It provides a fast setup and large support community. The big takeaway for Swagger is that it is designed as a bottom-up specification. Swagger specifies the behavior which affects the API to create more complex interlocking systems. RAML excels at supporting the entire API lifecycle and improves API-led connectivity. It provides a balance between developer tooling and technical writers without taking away from one or the other. It is also the fastest framework to ramp up your project. The main difference between the two is that RAML is a top-down specification. So the main difference between the two is that RAML is a top-down and Swagger is a bottom-up specification, meaning RAML breaks down the system and explains the behavior of the various subcomponents. So now we'll discuss about module number 2, API practices. So when we talk about APIs and their advantages, benefits, uses, and limitations, picking up the right API paradigm is very important. An API paradigm defines the interface exposing the backend data of a service to other applications. When starting out with APIs, organizations do not always consider all the factors that will make an API successful. As a result, there is not enough space built in to add the features they want in the later stage. This can also happen when the organization or product changes over time. So changing an API is difficult, but it is not impossible. To save the time, effort, and headaches, and to leave the space for new and exciting features, it is a good practice to give some thought to the protocols, patterns, and a few best practices before we get started. These factors will help us design an API that allows us to make the changes we want in the future. So to save the time, effort, and headaches, and to leave some space for the new and exciting features, it is a good practice to give some thought to protocols, patterns, and a few best practices before the people get started. This will help us design an API that allows to make the changes we want in the future. Over the years, multiple API practices have emerged. The REST API is more popular. We also have webhooks and WebSockets. So these are also the standards today. So let's dive into those different paradigms. The first we have is request response APIs. Request response APIs typically expose an interface through an HTTP-based web server. APIs define a set of endpoints. Clients make HTTP requests for data to those endpoints, and the server returns the responses. The response is typically sent back as JSON or XML. There are three common paradigms used by services to expose request response APIs. So the response is typically in JSON or XML format. So the most common architecture is REST, that is representational state transfer. So this is the most popular choice for the API development that is more famous today. The REST paradigm is used by companies like Google, Stripe, Twitter, and GitHub. This architecture is all about resources. A resource is an entity that can be identified, named, addressed, or handled on the web. REST APIs expose data as resources and use standard HTTP methods to represent create, read, update, and delete operations against these resources. For example, Google's API represents customers, charges, balance, refunds, events, files, and payouts as resources. So the REST API architecture follows some practices. So let's see what are those practices. The resources are part of URLs. For each resource, 2 URLs are generally implemented. One for the collection and one for the specific element. Nouns are used instead of verbs for resources. HTTP methods like get, post, update, and delete inform the server about the action to be performed. Different HTTP methods invoked on the same URL provide different functionality. So here /customer is used for the collection, whereas /customers/123 is used for a specific element. Nouns are used instead of verbs. HTTP methods like get, post, update, and delete inform the server about the action to be performed. Different methods invoked on the same URL provide different functionality. So the create uses post method for creating new resources. Read uses get method for reading the resources. So the get method never change the state of the resource. They have no side effects. The get method has a read-only semantic. Then update. Update uses put method for replacing the resource and patch for partial updates for existing resources. Then delete uses the delete function for deleting existing resources. REST APIs may return JSON or XML responses. Due to its simplicity and ease of use with JavaScript, JSON has become the standard for modern APIs. So let's see the HTTP methods which are typically used in REST APIs along with examples. So we will create the columns like operation, method, URL with /customers, URL with /customers/123. So operations are like create, read, update, delete. The method can be post, get, put or patch, delete. So the post with /customers creates a new resource. Get lists all resources. The put or patch updates the customers. Delete all customers. The post method for this URL is not applicable. The get method for this URL reads a customer with ID 123. The update, that is the patch or put method for this URL, updates the customer with ID 123. This is the delete method. A resource that exists only within another resource can be better represented as a sub-resource instead of a top-level resource in the URL. This makes the relationship clear for the developers using the API. show relationships. A resource that exists only within another resource can be better represented as a sub-resource instead of a top-level resource in the URL. This makes the relationship clear for the developers using the API. For instance, the GitHub API uses sub-resources to represent relationships in various APIs. For example, post / repositories / dot owner / repository / issues. It creates an issue. Then get / repos owner repo issues / number. It retrieves an issue. Get repositories owner repository issues. Lists all issues. Then patch repositories owner repository issues / number. Edits an issue. So beyond the typical CRUD operations, the REST APIs may sometimes need to represent some non-CRUD operations. So in that case, some approaches are commonly used. Then next we will see the next paradigm, that is RPC, which is the remote procedure call. This is one of the simplest API paradigms in which client executes a block of code on another server. We have seen that REST is about resources, but RPC is about actions. Clients typically pass a method and arguments to a server and receive back JSON or XML. So remote procedure call APIs generally follow two simple rules. The endpoints contain the name of the operation to be executed. Then API calls are made with the HTTP verb that is most appropriate. For example, get for read-only requests and post for others. So RPC style works great for APIs that expose a variety of actions that may have more complications than can be encapsulated with CRUD, or for which there are side effects unrelated to the resource at hand. RPC style APIs also accommodate complicated resource models or actions upon multiple types of resources. RPC style APIs are not exclusive to HTTP. There are other high performance protocols that are available for RPC style APIs, including Apache Thrift, and gRPC. Although there are JSON options for gRPC, both Thrift and gRPC requests are serialized. Structured data and clearly defined interfaces enable this serialization. Next, we will see GraphQL. So GraphQL is also a way the APIs are designed. GraphQL is a query language for APIs. It has gained significant popularity. It was developed by Facebook for its own use in 2012, before it was publicly released, and it has been adopted by various API providers like GitHub, Yelp, and Pinterest, etc. GraphQL allows clients to define structure of the data required, and the server returns exactly that structure. So if the query goes like this, Then the response from the server would go like this. So there are some minor advantages of GraphQL over REST and RPC. It saves multiple round trips. Avoids versioning. It has smaller payload size. It is strongly typed. So GraphQL enables clients to nest the queries and fetch data across resources in a single request. So in ordinary HTTP calls, it might become a little different because it requires multiple calls to the server. So mobile applications can use GraphQL for quick working, even on slow network connections. So the next is you can add new fields and types for GraphQL API without affecting existing queries. Similarly, deprecating existing fields is easier by doing log analysis. An API provider can figure out which clients are using a field. You can hide deprecated fields from tools and remove them when no clients are using them, which with REST and RPC APIs, it is harder to figure out which clients are using a deprecated field, making the removals more difficult. Then smaller payload size. REST and RPC APIs often end up responding with data that clients may not ever use. With GraphQL, clients can exactly specify what they need. The payload size can be smaller. GraphQL queries return predictable results while giving clients control over the data that is returned. Then it is strongly typed. GraphQL is strongly typed. So at the development time, GraphQL type checking helps in ensuring that a query is syntactically correct and valid. This makes building high quality, less error prone clients easy. Next, we have event-driven APIs with request response APIs for services with constantly changing data. The response can quickly become delayed. Developers who want to stay up to date with the changes in data often end up polling the API. With polling, developers constantly query API endpoints at a predetermined frequency and look for new data. If developers poll at a low frequency, their applications will not have data about all the events. So if developers poll at a low frequency, their apps will not have data about all the events that occurred since the last poll. However, polling at a high frequency would lead to a huge waste of resources, as most API calls will not return any new data. In one case, there was a study and it was found out that only about 1.5% of their polling API calls returned new data. To share the data about events in real time, there are three common mechanisms: webhooks, WebSockets, and HTTP streaming. So the first one is webhooks. Webhook is just a URL that accepts an HTTP post method. An API provider implementing webhooks will simply post a message to the configured URL when something happens. Unlike with request response APIs, with webhooks, you can receive updates in real time. Several API providers like GitHub and Zapier support webhooks. For instance, if you want to keep track of channels in a Slack team with Slack's web API, you might need to continuously poll the API for new channels. However, by configuring a webhook, you can simply receive a notification whenever a new channel is created. So a webhook is just a URL that accepts the HTTP post or get, put, or delete. An API provider implementing webhooks will simply post a message to the configured URL when something happens. Unlike with request response APIs, with webhooks, we can receive updates in real time. An API provider implementing webhooks will simply post a message to the configured URL when something happens. By configuring a webhook, you can simply receive a notification whenever a new channel is created. So, as shown in the figure, you can see the difference between polling and webhooks. So if you want to keep track of channels in a Slack team, for example, with Slack's web API, you may need to continuously poll the API for new channels. However, as you can see in the figure, By configuring a webhook, you can simply receive a notification whenever a new channel is created. So webhooks are great for easily sharing real-time data from one server to another server. From an application developer's point of view, it is typically easy to implement webhooks because it simply requires creating a new HTTP endpoints to receive events. This means that they can generally reuse existing infrastructure. At the same time, supporting webhooks adds new complexities like failures and retries, security, firewalls, noise. So supporting webhooks adds new complexities like failures and retries. So to ensure webhooks are delivered successfully, it's important to build a system that will retry webhook delivery on errors. Slack stops sending events to that webhook endpoint and notifies the developer. Then the security. Although there are standard ways of making REST API calls, security for webhooks is still evolving. With webhooks, the burden is on the application developers to ensure that they have received a legitimate webhook. That often leads to developers using unverified webhooks. There are some common patterns that most API providers follow to secure the webhooks. Then the firewalls. Applications running behind firewalls can access APIs over HTTP, but they are unable to receive inbound traffic. For such applications, utilizing webhooks is difficult and often not possible. Then noise. Typically, each webhook represents one single event. When there are thousands of events happening in a short time that needs to be sent via a single webhook, and it can be noisy. Then we have WebSockets. WebSockets is a protocol used to establish a two-way streaming communication channel over the single transport control protocol connection. Although the protocol is generally used between a web client and a server, it is sometimes used for server-to-server communication as well. So WebSocket is a protocol used to establish a two-way streaming communication channel over a single TCP connection. Although the protocol is generally used between a web client and a server, it's sometimes used for server-to-server communication as well. It is supported by major browsers and often used by real-time applications. Slacks use WebSockets to send all kinds of events happening in a workspace to its clients, including new messages, emoji reactions, and channel creations. Slack also provides a WebSocket-based real-time messaging API to developers so that they can receive events from Slack in real time and send messages as users. Blockchain also uses its WebSocket API to send real-time notifications about new transactions and blocks. So WebSockets enable full duplex communication means the server and clients can communicate with each other parallelly, simultaneously. And the overhead is also less. They are designed to work over port number 80, enabling them to work with firewalls that might block other ports. This is an especially important consideration when it comes to enterprise developers. For example, some enterprise developers using Slack APIs prefer to use WebSocket API over Webhooks because they are able to receive events from the Slack API securely without having to open up an HTTP webhook endpoint to the internet where Slack can post messages. WebSocket are great for fast live streaming data and long-lived connections. However, we need to be careful if we plan to make these available on mobile devices or in regions where connectivity can be spotty. Clients are supposed to keep the connection alive. If the connection dies, the client needs to reinitiate it. There are also issues related to scalability. Developers using Slack's WebSocket API must establish a connection for each team that uses their application. This means that if an app is installed on 10,000 Slack workspaces, the developer would be responsible for maintaining 10,000 connections between Slack servers and the app's server. Next, we will see HTTP streaming. So with the help of HTTP request response APIs, clients can send an HTTP request and the server returns a response of a finite length. So that we will see along with the diagram. Now it's possible to make the length of this response indefinite. With HTTP streaming, the server can continue to push new data in a single long-lived connection opened by a client. So as you can see in the diagram, the response is of finite length. So now it's possible to make the length of this response indefinite. With HTTP streaming, the server can continue to push new data in a single long-lived connection opened by a client. To transmit data over the persistent connection from server to client, there are two options. The first option is for the server to set the transfer encoding header to chunk. So to transmit data over the persistent connection from server to client, there are two options. The first is for the server to set the transfer encoding header to chunk. This indicates to clients that data will be arriving in chunks of new line delimited strings. For typical application developers, this is easy to pass. Another option is to stream data via server sent events, known as SSE. This option is great for clients consuming these events in a browser because they can use the standardized event source API. Twitter utilizes the HTTP streaming protocol to deliver data through a single connection opened between an application and Twitter's streaming API. The big benefit for developers is that they don't need to poll the Twitter API continuously for new tweets. Twitter's streaming API can push new tweets over a single HTTP connection instead of a custom protocol. This saves resources for both Twitter and the developer. So the big benefit for developers is that they don't need to poll the Twitter API continuously for new tweets. Twitter's streaming API can push new tweets over a single connection instead of a custom protocol. HTTP streaming is easy to consume, but one of the issues with it is related to buffering. Clients and proxies have buffer limits. They might not start rendering data to the application until a threshold is met. Also, if clients want to frequently change what kind of events they listen to, streaming may not be ideal because it requires connections. So now let's summarize by comparing the difference between various event-driven API options. So there is no standard solution when it comes to selecting an API paradigm. Each of these work well for certain kinds of use cases. You might need to support multiple paradigms also. For example, the Slack API supports RPC, WebSockets, and Webhooks. It is important for you to understand which solution will work best, which will help you meet your business goals and what is possible with the constraints within which you are working.